Welcome to the DIY Honda Garage channel. The DTC P2127 indicates an issue with the APP sensor B, specifically related to the throttle position TP sensor E, which is signaling low voltage. In vehicles like the Honda HR-V from 2016 to 2022, this sensor plays a critical role in providing accurate throttle position data to the Powertrain Control Module, PCM, ensuring optimal engine performance and efficiency. The APP sensor is generally located near the accelerator pedal, where it detects the position of the pedal and relays this information to the throttle body. A low voltage reading can affect how the engine responds, leading to potential drivability issues. Therefore, addressing this DTC promptly is crucial for maintaining vehicle performance and safety. In this troubleshooting guide, we will outline detailed steps and checks to effectively diagnose and resolve this issue. The DTC P2127 pertains to the APP sensor B, more technically referred to as the throttle position sensor E, indicating that the circuit is detecting low voltage. The APP sensor's primary function is to monitor the position of the accelerator pedal, converting the mechanical input into an electrical signal for the PCM. By doing so, it allows the engine to adjust throttle position for efficient operation. In terms of location, the APP sensor is situated on the accelerator pedal assembly, making it susceptible to wear or electrical issues due to its exposure to constant movement. A low voltage signal from this sensor may cause the vehicle to experience inconsistent acceleration, stalling, or even trouble starting. The implications of this DTC can significantly affect the vehicle's operational capability and lead to more severe problems if not addressed. When diagnosing the DTC P2127, several potential causes must be considered. Firstly, a faulty APP sensor is a prominent suspect that can lead to a drop in voltage. This can happen due to internal failures or wear over time. Secondly, issues with the APS2 wire, whether a short circuit or an open wire, can also cause lower voltage signals to be sent to the PCM. This can occur from corrosion, damage, or making poor connections along the wire. Lastly, problems with the VCC5 wire can also contribute to this DTC. If there are open circuits or disconnections, the necessary voltage won't reach the APP sensor, leading to low voltage readings and ultimately triggering this diagnostic trouble code. The DTC P2127 can manifest several noticeable symptoms during vehicle operation. One primary symptom is an unresponsive accelerator pedal, where pressing down produces little to no acceleration. This can be particularly dangerous, as it may severely limit the vehicle's responsiveness in critical driving situations. Additionally, drivers may experience inconsistent engine performance, which can include erratic power delivery or faltering during acceleration. The vehicle might also stall unexpectedly or exhibit rough idling due to miscommunication between the APP sensor and the PCM. These symptoms not only compromise vehicle drivability, but could pose safety hazards for both the driver and surrounding vehicles. The first troubleshooting step for DTC P2127 involves verifying the problem by turning the vehicle to the on mode without starting it, and then checking the values of the APP sensor B using the Honda Diagnostics System, HDS. This step is crucial to confirm whether the signal condition matches the expected threshold of less than 0.2 volts. If the values align, the failure is confirmed, and the technician can proceed to the next step. Conversely, if the values do not match, it indicates that the system may be operating correctly at that moment, but further investigation is warranted. In this case, technicians should check for loose connections or other electrical concerns linking the APP sensor and the PCM, as intermittent failures may not always present apparent symptoms. In this step, the technician should turn the vehicle off and then disconnect the 6-pin connector from the APP sensor to begin checking for voltage. After disconnecting, the vehicle should again be turned to the on mode to measure the voltage between the designated test points on the APP sensor connector. Specifically, one must check between test point 1, wire number 1, and test point 2, wire number 2. A voltage reading around 5.0 volts indicates that the VCC5 line is functioning correctly, signifying that the power supply to the APP sensor is intact. If the voltage does not meet the expected value, it will necessitate further investigation, possibly indicating issues with the VCC5 line or the wiring connected to the APP sensor, requiring appropriate repairs. For the third step of troubleshooting DTC P2127, begin by turning the ignition to the off position and then using the HDS to jump the System Communication Service (SCS) line. This prepares the system for further checks. Next, the technician should disconnect the PCM connector A51P and check for continuity between the specific test points from the APP sensor connector number 3 to the body ground. A reading confirming continuity indicates that there is a short in the APS2 wire, specifically between the PCM and the APP sensor. If continuity does not exist, it shows that the APS2 wire isn't shorted, allowing you to progress to subsequent checks involving potential open circuits that could hinder proper functionality. In this step, the technician will need to jump terminals A and B within the APP sensor connector, establishing a connection from number 3 to the body ground. This action allows the technician to then check for continuity between the circuit at test point 1, PCM, connector A, number 29, and test point 2, body ground. Achieving continuity at this stage implies that the APS2 wire is functioning correctly and is free of breaks or faults that would cause DTC P2127. Should continuity not be found, it necessitates addressing the open circuit in the APS2 wire located between the PCM and the APP sensor, ensuring that all electrical pathways are intact. Step 5 requires the technician to reconnect the PCM connector A51P and remove the jumper wire previously used on the APP sensor connector. Following this, a new jumper wire should be connected between APP sensor number 1 and number 3. With the vehicle turned to the on mode, the technician will then check the APP sensor B values using the HDS. If the readings confirm the threshold of less than 0.2 volts, the technician should look to update the PCM software or replace it with a known good unit, as either action may resolve the issue. If the DTC P2127 is cleared after completing these actions, the troubleshooting process is finished. However, if the error persists, it indicates the need to replace the APP sensor, highlighting its role in maintaining accurate throttle input to the PCM. The final troubleshooting step addresses the VCC5 line. To begin, turn the vehicle to the off mode, and again, use the HDS to jump the SCS line. After disconnecting the PCM connector A51P, establish a connection between APP sensor number 1 and body ground using a jumper wire. Subsequently, measure the continuity between test point 1, PCM connector A, number 37, and body ground. If continuity is verified, it indicates the VCC5 wire is functioning properly. In this case, technicians should consider updating the PCM software or substituting it with a known good unit. If continuity is not established, it demonstrates an open circuit in the VCC5 wire, necessitating repair work to restore proper voltage supply to the APP sensor and resolve the DTC P2127 effectively. After completing all troubleshooting steps for DTC P2127, it is imperative to perform a final repair verification. Initially, recheck the DTC codes in the HDS to ensure that DTC P2127 has been cleared successfully. If the error persists, it indicates that additional issues may remain unresolved. Next, confirm that the vehicle operates smoothly, without any misfires or hesitations indicative of throttle signal errors. Finally, assess the responses of the APP sensor to ensure correct dynamic performance as the accelerator pedal is pressed and released. This verification process ensures that all repairs effectively addressed the source of the issue, enabling the vehicle to perform optimally on the road. To help prevent issues similar to DTC P2127 from occurring, it is recommended to implement regular preventive maintenance. Start by routinely inspecting electrical connectors associated with the APP sensor and the PCM for signs of wear, corrosion, or loose connections. Such preventive checks can identify issues before they trigger diagnostic trouble codes. Additionally, it is prudent to examine the wiring for signs of abrasion or damage due to environmental factors. Proper maintenance of software updates for the PCM is also crucial, as outdated software can lead to miscommunication between components. Consistently addressing these preventive measures helps maintain effective vehicle performance and mitigate the likelihood of future DTC occurrences. In summary, understanding the role of the APP sensor in the vehicle's performance is paramount when addressing DTC P2127. Following systematic troubleshooting steps allows technicians to identify and resolve issues effectively. With thorough checks on voltage supply, continuity, and potential faults within the wiring, one can isolate the problem accurately. Performing regular maintenance ensures that electrical connections remain sound and wires remain undamaged, ultimately preventing future issues. Having a diligent approach to vehicle diagnostics and repairs leads to reliable performance and enhances the safety of driving, especially in essential vehicle systems like throttle control. Please like and subscribe to the channel. See you next time.